cube is expanding in such a way that its sides are changing at a rate of 3 centimeters per second. We are required to find the rate of change of the total surface area when its volume is 125 cm cubed. The first thing we need to do when solving connected rates of change problems is to identify the variables involved. So I have broken this solution down into 4 steps. The first of which is to identify the variables involved. So we read the question carefully and all the variables will show themselves. A cube is expanding in such a way that its sides are changing at a rate of 3 centimeters per second. So one variable already that we should see is the length of a side. That's one variable. At a rate of, now the word rate is a function of time. We use it in our everyday language, and rate is a function of time. The rate of doing something means how quickly can we do it. The rate of completing a task, how long will it take for us to complete that task. So rate should be remembered as a function of time. A rates of change question will always involve time as one of the variables. Reading on. Find the rate of change of the total surface area. Total surface area is another variable. When its volume is 125 cm cubed. So this question makes mention of 4 different variables. We should denote each one with a symbol. So we will let x represent the length of a side. Time will be represented with a common T. Total surface area with a capital A. And capital V is usually used to represent volume. Now that we have denoted all our variables, we can get into the question. Step 2. We should write down any rates that are given in the question to assist us. A cube is expanding in such a way that its sides are changing at a rate of 3 centimeters per second. So the length of a side is changing at a rate of 3 centimeters per second. Length of a side is x, rate, so that's dx dt. The x dt is equal to 3 centimeters per second. Now note that the cube is expanding, which means that it's increasing in size, and therefore the length of the sides will also be increasing, which is why we have a positive 3 centimeters per second. That's useful to note. Determine which rate we are being asked to calculate. Here it is. Find the rate of change of the total surface area. Rate of change of surface area, so that's surface area over time. dA dt is what we want to find. Note that it asks us to find the rate of change. Change can be positive or negative. We would expect a positive answer for dA dt. Since the cube is expanding, it means that the total surface area should be increasing. So our rate of change in this case should be an increase. So we would expect a positive answer at the end. Our 4th step is to find the missing link in the chain. So we are going to link dA dt, which is what we are trying to find, with dx dt. we want to find dA dt. Once again, we have dx dt. So we have dt as the denominator on the left, dt as the denominator on the right. dA is the numerator on the left, so we do not want a dx. We need to eliminate this dx by cancelling. So this missing link, this ratio that we want to find, should have dx as the denominator, and as you should see, dA should be the numerator, so that dA dx by dx dt is equivalent to dA dt. This here is our missing link. This tells us that we need to find a relationship between A and X. We need to get A in terms of X. That's the total surface area of a cube in terms of the length of a side of a cube. You should recall that a cube has 6 identical faces. Each one is a square. And the length of a side of that square in this question, we took it to be X. So the area of each face is x squared, and therefore the total surface area will be 6 times x squared. A is equal to 6x squared, and this is how we link A with x. Once we differentiate A with respect to x, we will obtain dA dx, and that's of course equal to 12x. We need to know what x is. How are we going to find x? Recall that the volume at this instant, when we want to find the rate of change of total surface area, the volume is 125 centimeters cubed. This is the only role that volume plays in this question. Notice that volume was not involved in linking this chain. The only role that volume plays is to allow us to calculate x. The volume of a cube is side by side by side, which is x by x by x, or x cubed in this question, and we are being told that that is equal to 125. Therefore, x is equal to the cube root of 125, which is 5 centimeters. And therefore, dA dx at this instant will be 12 times 5, which is 60. And the units would be total surface area, centimeters squared over length of a side, centimeters. Cm squared over cm is equal to cm. So dA dx is 60 centimeters at that instant. Now we can calculate dA dt. It's equal to dA dx, which is 60 centimeters, times dx dt, which was given as 3 centimeters per second, and that is 180 centimeters squared per second. Always be sure that